It is safe to say that without the humble battery, modern technology would not exist. Anything that needs the energy to work but is not always connected to a power source, such as heart pacemakers, smartwatches, and electric cars, has some form of battery. The battery industry has become one of the hottest in recent years due to competition to provide the best battery in its class. A new battery material has come and is surprising the entire industry, despite the fact that several battery materials have been tested. It has a 28,000-year working life and is a nuclear diamond battery. What is this new battery exactly? Why is it so well liked, and how does it work? It is appropriate to discuss the amazing nuclear diamond battery that blew everyone's mind. Which option, using nuclear waste to power your electric vehicle or smartphone, would you pick? Many people tremble when nuclear materials are mentioned because they emit dangerous radiation. However, the waste produced during the nuclear power generation process may one day serve as an energy source. Compared to the common lithium-ion batteries that are all around us, nuclear diamond batteries offer a noticeable improvement. Although lithium-ion batteries have had a significant impact on the development of electronic gadgets, they do have various shortcomings that are significant enough to motivate researchers to keep developing new battery technologies. The shortcomings of lithium-ion batteries are no more apparent than in electric cars, thanks to their low energy density. Due to their low energy density, lithium-ion batteries' drawbacks aren't as obvious as in electric vehicles. Lithium batteries must be bulky in order to provide respectable driving ranges, but fall short of gas-powered cars in terms of the distance they can go on a full tank. Some people are reluctant to accept electric vehicles. Lithium-ion battery charging also requires a lot of time. You might need to wait for the battery to completely recharge for around an hour, even with the fastest charger. When you consider how rapidly you can fill the gas tank of a nice automobile, this is hardly the ideal situation. Lithium-ion batteries are also expensive. The most expensive component of an electric car, despite significant cost reductions, is still the battery. Because of the battery, electric cars are actually far more expensive than their gasoline-powered counterparts and are therefore out of the price range of the majority of car buyers. Another concern is lithium batteries' durability. All lithium-ion batteries are susceptible to degradation, which causes a continuous decline in capacity over time. In gadgets like smartphones, where the batteries may struggle to hold a good charge after a few years of use, the issue is more visible. If you take your smartphone from 3 years ago, you'll discover that it doesn't last as long as it did when it was new. In electric cars, you must replace the battery when degradation lowers the capacity to a specific percentage, even while the rest of the car is still in excellent shape. Scientists have been experimenting with various battery materials and compositions in an effort to develop the perfect battery. But replacing the battery is a pricey process. For instance, solid-state batteries, a developed type of lithium-ion battery with advantages such as better safety and greater energy density, have attracted interest. Nobody can promise that nuclear diamond batteries will endure as long as, for example, graphene or lossless batteries. These batteries are advantageous to the environment since they remove possible risks of public safety and have a lifespan of thousands of years. Consider the 28,000 years your smartphone's battery will last. In that case, the battery will outlive the phone. In 2016, a team of academics, physicists, and chemists from the University of Bristol began work on what they called a beta Voltaic device. The term was chosen because beta decay was fueled by nuclear waste. The batteries were later known as radioactive diamond batteries. Beta decay happens when some excess particles in an atom's nucleus are released to make the proton-to-neutron ratio more stable. This causes the creation of beta radiation, a form of ionizing radiation that contains many beta particles, also referred to as high-speed, high-energy electrons or positrons. In a conventional beta voltaic cell, radioactive material is placed between thin layers of semiconductors. Beta particles produced by nuclear decay knock semiconductor electrons loose and cause an electric current to flow. However, as the radioactive source is moved further away from the semiconductor, its power density falls. This means that nuclear batteries are much less efficient than other types of batteries, but there is a fix for this. These radioactive batteries are produced using the process called chemical vapor deposition, also known as PCD or polycrystalline diamond, but by using radioactive methane that contains the radioactive isotope carbon-14, which may be created from a radiated reactor of graphite blocks. Scientists have modified the process to produce radioactive diamonds. Artificial diamonds are routinely made using this technique. These diamonds can behave as a radioactive source and to semiconductor when exposed to beta radiation. You'll get a battery that has a lengthy lifespan and doesn't need to be charged. Thanks to the radioactive waste that fills its inside, it can recharge itself endlessly with little to no observable degradation over hundreds of years. The theoretical life of a battery is more than 1,000 years. It doesn't need to be charged, changed, or even maintained. One of the startups working on nuclear diamond batteries is the Nanodiamond Battery, or NDB. The company bases its batteries on powerful diamond-based alpha, beta, and neutron voltaic formulae for long-lasting and green energy batteries. From tiny insulin pumps to space rovers probing Mars' surface, it aims to offer long-term, independent power. NDB has built their nuclear diamond batteries out of layers of very thin paneled nanodiamonds. For purposes of context, a nanometer is 1/1000th of a meter. The company prefers diamonds because of their excellent heat conductivity, which makes them ideal for electronic devices. They are the most well-known natural heat conductors and are 3 to 4 times as effective as copper or silver. The exact process utilized to make these diamonds is known as chemical vapor deposition, which involves using gases at extremely high temperatures to encourage carbon to crystallize on a substrate material. However, compared to ordinary diamonds, the ones made using this approach are bluer and more conductive. Although rare and more expensive than synthetic diamonds, blue diamonds can be found naturally. NDB first sources the nanodiamonds before producing the radioactive isotopes. NDB uses radioactive isotopes of uranium and plutonium that are left behind from nuclear power reactors. A few square millimeter single crystal diamonds are capable of transferring heat from radioactively decaying isotopes so quickly that electricity is generated in the process. The NDB transducer stores the energy from the decay sources and converts the kinetic energy of the incident radiation into electrical energy. Even while battery cells can be combined in large numbers, only a small amount of energy can be produced by each one to regularly provide electricity for large devices. The NDB touts the small size of the nanodiamond battery cells as a benefit for scalability. For a wristwatch, which consumes roughly 2 microwatts of power, a small NDB cell is appropriate. However, if you need to power a different application, you can increase the quantity of stacked cells to meet the demand. They imagine nuclear diamond batteries powering satellites or other spacecraft. The classic Voyager's NASA probes, which did not use much power when they were launched in 1977, are an excellent example. They each possess 3 radioisotope thermoelectric generators, each with a power output of several hundred watts. Each generator's original power output was only 158 watts, or roughly enough to power a typical residential light fixture for a year. NASA has been shutting off functions to prolong the battery life of the Voyagers since they have been in orbit for decades. After 10 more years, they might pass away, at which point we would be unable to get in touch with them. However, when powered by radioactive diamond batteries, they can last for what seems like an eternity. Instead of requiring recurring surgeries to repair them when their batteries run out, technological devices can be implanted on this planet once in a person's lifetime. NDB plans to create a smartwatch. It's scheduled to go on sale in 2022. One watch with one battery may be passed down through the generations without ever needing to be changed. If it happens, talk about an electronic heirloom. Naturally, the NDB still keeps some information regarding their nuclear diamond batteries a secret. For instance, we are not familiar with power density. However, the most crucial thing right now is nuclear diamond batteries, not vaporware. In reality, we'll soon be employing these, because using nuclear waste in this way is healthy for the environment. For instance, there are around 95,000 tons worth of graphite blocks in the UK. They become less radioactive when carbon-14 is removed from them, which lowers the expense and difficulties of safely keeping them.